हरि करना।
So with this, it's a wrap for our types of sampling. So we have seen probability sampling techniques, simple random sampling, stratified random sampling, cluster sampling, systematic sampling. Then we looked into non-probability sampling, that's convenience sampling, purposive sampling, snowball sampling, quarter sampling also. Then finally we moved on to the mixed method sampling. So here we have seen sequential sampling, embedded sampling. So with this, it's a wrap up for types of sampling section in intuitive sampling and distribution for you course. So we will wrap this section completely with after finishing the following thing, that is choosing the optimal sample size. This is very important. This is very important. That's the reason I kept it aside. I kept it at the last, because after looking into all the concepts of sampling methodology, then if you come to this, you can clearly understand that. That's the reason I put it at the last. So choosing the optimal sample size, a comprehensive guide for you. So choosing the optimal sample size is a crucial step in conducting research or surveys, as it affects the accuracy and reliability of the results. So, here we have a comprehensive guide to help you determine the optimal sample size for your research or survey. Okay, so what I'm going to do here is, we have 7 steps in this comprehensive guide. I will explain each step theoretically, then we will take up an example. Now we will take up a single example and we'll explain that single example using all these steps, and finally we'll calculate the optimal sample size for that. I hope you got my point. It would help. It would help you. Okay, it helps actually. It helps actually. So let's start. The first step in our comprehensive guide in choosing the optimal sample size is define your research question. So before determining the sample size, you should clearly define your research question, including the variables you want to measure and the population you want to study. Okay. So now let's take one a simple example. Okay. Simple example. So this one is choosing the optimal sample size. So step 1 is to define your research question. So now we will take one simple example. So my research question is, what is the average average age of customers who purchase products from a specific online store? Okay, that's what is my research question. Done. Now we'll get back to the second step. So what's the second step? Just a minute, I'll get back to my slide. So yeah, this is our second step in this. Determine the level of precision you need. So the level of precision you need depends on the margin of error you can tolerate. A smaller margin of error requires a larger sample size. Very important point. Very important. A smaller margin of error requires a larger sample size, while a larger margin of error can be achieved with a smaller sample size. So step 2, is determine the level of precision you need. So the level of precision you need depends on the margin of error you can tolerate, correct? Let's take how much would be better for this example. Let me check. I will go for the 3 years is fine. Is 3 years okay? So let's say I want to have a margin of error. Margin of error is equal to plus or minus 3 years. This is fine, I guess. Plus or minus 3 years. So this means that we want a 95 percentage confident that the true average age of customers is within plus or minus 3 years. 3 years of the sample mean. So always we want 95% confidence. That means the true average age of customers should be within plus or minus 3 years of the sample mean. Next, let's get back to the slide. Yeah. So next step is calculate the population size. The population size affects the sample size calculation. If the population is large, a smaller proportion of the population needs to be sampled to achieve the same level of precision. Okay? If the population is large, a smaller proportion of the population needs to be sampled to achieve the same level of precision. So let's imagine the population size. How much would be better? 5,000 or 10,000? Which one would be better? Okay, let's take it. Step 3, calculate the population size. So let's assume that the online store has 10,000 customers. So n is equal to 10,000. Let me put it 10,000 customers. Let's imagine that online store, some specific online store, we are not worried about the name. Online store has 10,000 customers. So n is equals to 10,000 in this case. Okay. So next step that we have here is choose the desired confidence level. Choose the desired confidence level. The confidence level is the probability that the sample accurately represents the population. The commonly used confidence level is 95%, which means that there is a 95% chance that the sample is representative of the population. Okay, that's what is the choosing the desired confidence level. Let me put it here. So step 4, choose the desired confidence level. Desired confidence level. So here what will we do is we will go with the 95% of confidence level. So we'll go with the 95% of confidence level. Simple. This is very simple. Okay. Now step 5 is to calculate the sample size, the most important step. So once you have determined the level of precision, population size and desired confidence level, you can calculate the sample size using statistical formulas or online calculator. If you want to use, you can directly use online calculators. It is not a big deal. So there are different formulas for different types of sampling methods, but let's take a simple one to do the sampling size calculation for our example. Okay, let me come here. So okay, step 1, step 2, step 3, step 4. Now step 5 is to calculate the sample size. So let's take a simple formula. So n is equal to z power 2 multiplication of p multiplication of q all divided by e power 2. Okay, this is what the formula, where n is the sample size and z is the g-score and z is the g-score associated with the desired confidence level. G-score associated with the desired confidence level. Then that's, of course, here it's 95%. Let me write it down. 95%. Then P is the estimated proportion of customers in the population. Then Q is the 1 minus P. Anyway, we'll be getting into the statistics, in statistical inferences, not to worry. And finally, E is the margin of error. Margin of error. So let's assume that we don't know the proportion of customers in the population. In this case, we can use a conservative estimate of p is equals to 0.5. Let's take the p value is equals to 0.5. Okay, and let's put it into the formula. N is equal to 1.96 power 2 multiplied by 0.5 times 0.5 all divided by our margin of error. Let's take 3. Of course, that's what we have decided upon, plus or minus 3 years. So square and sorry. So let's print n and see. Print n. So the calculated sample size, the calculated sample size is that's it. You got it around. There is 1.96 power 2. So okay, you just need to multiply this with just a minute. Let me put whole thing into the bracket. Yeah, just give me some time. Yeah, that's it. This is your sample size 106.71. Just make it into 107 and n is equals to 107. That's what is your sample size. So that's it. With this, you got your sample size, but there is more to it. There is more to it. Let me tell you that. So next, what we have to do is, once you have calculated the sample size, next few more factors you have to consider. That is, consider the practical limitations also. So in addition to statistical considerations, whatever we have done are the statistical considerations. Now we have to consider the practical limitations. You should also consider the practical limitations such as budget constraints, time constraints, and availability of participants. A larger sample size requires more resources and time. So in this case, step 6 is to consider the practical limitations. Consider the practical limitations. That is 3. Yeah. So in practice, we may face several practical limitations such as budget constraints and time constraints and availability of participants. In this case, we may need to adjust the sample size based on these limitations. For example, if we have a limited budget or time, we may need to reduce the sample size to a feasible level. If we have a limited budget or time, we may need to reduce the sample size to a feasible level. Okay, so that's it, and let's look into the final step of it. So that is pilot test your survey or instrument. So obviously you should pilot test your instrument or survey to ensure that it is valid and reliable. That's common in every research. So step 7, so pilot test your survey or instrument. So before conducting the survey, we should pilot test our survey instrument to ensure that it is valid and reliable. So this can help us identify any issues or problems that may affect the accuracy of our results. So in this case, we may want to test our survey with a small group of customers to ensure that the questions are clear and understandable and that the response are reliable. So in this case, we may want to test our survey with a small group of customers to ensure that the questions are clear and understandable and that the responses are reliable. So that's it. All steps are covered. With this, we can come up with an optimal sample size. So in summary, to determine the optimal sample size for our research question, we followed the steps of defining our research question, determining the level of precision, calculating the population size and desired confidence level, then calculating the sample size using a formula, then finally considering practical limitations and pilot testing our survey instrument.